Today we're going to analyze the pictures that you took as you projected that marshmallow with your catapult. And so we're going to upload the pictures and take a look at different points of the graph. So if you go to Google Classroom, there'll be a link to this Desmos activity. And here's what it looks like. Let's analyze your catapult. We're going to upload the two pictures, so I'll show you how to do that. And if you didn't have the pictures, if you didn't do the catapult, or if you didn't have the pictures, you'll be able to still complete the investigation. So if we take a look, I've already uploaded my picture, but the instructions are here. You're going to press this plus sign, and then there's an image, and then you're going to select the image that you want to upload. And then when you do that, I think I might have deleted mine here. I wonder if I have a different image I can use. Okay, so I'm just going to pick an image, and I'll kind of show you what to do. All right, so I'm just going to pick an image. And if you see this image right here, which was what we used for our strengths builder, it centers it at 0, 0. And you want to move it so that you can see the starting point and the ending point of your marshmallow. So to do that, you're going to take a look at the lower left-hand corner and find the vertices of that. So this looks like about -4, -5. And then what you're going to do is you're going to click on that image and change it to the opposite. So I said -4, -5, and I'll do 4 and then 5. And then you'll see that that image did center right here where it was supposed to. So again, you can edit it by just doing the opposite of that left-hand vertex. I did that with mine already, and I centered it so that here was the ground right here, and it matches with the x-axis. So I'll play around with that. Again, you look for your lower left-hand corner and do the opposite and make that the center of your image, and it puts it right where you want it to be. All right, once you have that, we're going to take a look at matching our equations with this kind of trajectory that we have. So if you do have questions in class on how to upload your picture, you can let me know. But otherwise, if you don't have a picture, or if you don't like the picture that you have, you can definitely use this one right here already in your Desmos. All right, so once you upload it, there are 3 forms of an equation that we're going to look at. One is called standard form, ax squared plus bx plus c. One is called vertex form. Again, there's the a and the x, but now it has a minus h squared plus a k. And then there's something called the factor form. Factor form, again, using the same a value, but now we have this thing called an r1 and an r2 value. So we're going to play around with these sliders and see if we can get them to match our parabola. So I'm just going to play around looking at what a does. If you notice, if a is positive, it makes a smiley face. And if a is negative, it turns upside down. And I want my graph to be upside down, so I'm just going to, I don't know, pick a number. Okay, so let's pick a number. And then I'm going to play with my b value. What is that doing? Oh, it's moving it up, which is what I want. Play with my c value. What is c value? Oh, it moves it up or down. Oh, okay, okay. So I'm just going to play with this until I get a graph that I like. It's kind of putsy and finicky, so excuse me while I play with this. Okay, this one's not bad. Okay, that one's not bad either. I can get like most of the graph, and then this kind of gets cut off here. So I'm happy with the red. I'm going to look at the blue. Vertex form. If you remember vertex form, we're talking about h and k, left and right. Hopefully that helps you. So using what I know about h and k, I can kind of play around with this and get a graph that I like right here. All right, so there's one that I'm pretty happy with. Okay, and then I'm going to take a look at factored form. And again, just playing around with it, we can take a look and see what these do here. Oh. All right, and I'm pretty happy with that one right there. It's not, can I get it any better? I mean, not really, huh? Okay, that one, I would accept that one. And let's take a look at this one right here. I want to change this one just a little bit more. Okay, so though I'm pretty happy with those 3 graphs. Again, we're going to take a look at, all right, what does standard form tell you in a graph? What does factored form? And what does vertex form tell you in an equation? So that's what the next 3 slides are. They want you to input these numbers and look at the equation. So here they are. Oh, let's label. So the vertex is the highest point, and I wonder why my marshmallows didn't show up. Okay, so my marshmallows should have showed up, but they didn't. So let's take a look at the vertex. The highest point was somewhere like right around here. So that's my vertex. And then my y-intercept is right here. So I'll call that my y-intercept. My x-intercept was like right here. And I had another x-intercept like somewhere over here. So I'll call those my x-intercepts. So I'll just put x. Okay, so we can label those. We talked about those on day 1 of quadratics. Vertex is the highest or lowest point where it changes direction. The y-intercept is at time 0. And then the x-intercept is where it crosses the x-axis. So now let's take a look at standard form of an equation. What did you get for A, B, and C? So this does require kind of a lot of flipping back to the slides. So let's see if I can put these numbers in. So we have y equals, and the a value was negative. It turned it upside down. And then we have x squared. To get this squared, we'll just hit the keyboard and you can get the squared. And then it was, I think, plus 1.7, but I forgot, so I'm going to flip back. 1.7, so plus 1.7. And then it's an x, so notice there's ax squared plus bx plus c. Plus c, I got about 0.7. And then the starting height was the 0.7. So if I took a look at my graph right here, my starting height, about 0.7 is where it started, it went up, and then it went down. So the question is, in standard form, we have all these numbers, where do you see the starting height? And if you notice, it is the C value. So whatever the C value is, that will be the starting point of my graph. So standard point tells you the starting value. It's just that last number without the X. So where does the starting height show up? It's the C value. Okay, let's take a look at the next equation, vertex equation. And again, I'm just going to type in, it was that same A value. It was negative, I think, 0.2. But again, we can flip back if we forgot. So there's the A value, negative 0.2. H was 4, K was 4.2. So if we type it into the equation, it's x minus my H value, which is 4. We'll square it. And then it was plus, what did I have? 4 points. What was it? Did I say 2? I heard out already. So 4.2. Okay, so 4.2. All right, what is the highest point of our graph? It was actually 4.2. Again, if we want to go back and look, so there it is, about 4.2, I would estimate to be that highest point of the graph, and the blue and the red were closer to it. So again, where's the highest point represented? Well, it's going to be the opposite of the H value, and then it's going to be the same as the K value. So if you remember back in the functions unit in first semester, we talked about H and K. H is left and right. It's the opposite of what you think. So the opposite of negative 4 is 4. And then K is what you think. That's up and down. So we went up 4.2. So it's going to be the opposite of H. And then the K value will stay the same. That will be the vertex. So we've actually already studied how to find the vertex of a quadratic, looking at H and K. And last is factored form, so we're going to type this in. Y equals, the A value was the same, negative 0.2. And then it's going to be x minus the R1 value, and my R1 value was negative 0.1, I believe. Or here's 8 and negative 0.7, so 8. So I'm going to have x minus 8. And then x plus 0.7 because it was negative. And then it says what was the distance that it landed on the ground. So if we go back to our graph right here, mine landed, oops, I zoomed out. Can I zoom back in? Yes. Mine landed here at 8. Okay, so what does factored form tell us? It tells us when it lands on the ground, and it's going to be the opposite of the factor. So we have x minus 8, and it landed on the ground, opposite of the factor. That'll be the landing distance. What does the other value represent? Well, it represents like, okay, the starting value was like 0.7 right here, but the other factor, the negative 0.7, that would be like this point over here. So it's the other x-intercept, would be that right there. So the other x-intercept would be this guy right here, would be the other factor. Okay, so let's sort these cards into piles. So first was vertex. Where do we find the vertex? Oh, using vertex form. And the vertex was the highest point on the graph. The starting height was like that standard form. And here's standard form, the ax squared plus bx plus c. And that gave us the y-intercept. Do I have the standard form equation? I don't see it. Okay, and then, ooh, I'm hiding a card here. Oh, this was the starting value, 0c. All right, where the marshmallow hit the ground, that was these things called roots, R1 and R2, and it gives us the x-intercepts, and it came from there. Ooh, H and K, that's the vertex. All right, so I've matched them up right here, and we can check our answer. Yay, we got them all right. Okay, so, I mean, it was a lot of playing around with and analyzing your data, so I just kind of put together a summary of what we've done here. So here's my graph, here's my picture, and again, standard form tells us the starting value at time 0, so the starting value. So again, here's what standard form is. Where did it start at? It started at this 0.7 right here. So here, the standard form tells us the starting value. The vertex form, here's the vertex. Vertex was about right here, and that was at about 4.2. And how can we get vertex from vertex form? Well, it's the opposite of what's in the parentheses, and then I had 4.3 for this one that I did. So it's left and right, so it went right 4, and then it went up 4.3. So if I give you something in vertex form, it will tell us the opposite of the h value will be how far to the right, left or right, and then the thing on the outside of the parentheses will tell us how far up or down. And then factored form tells us where it lands, the x-intercepts. So here the x-intercept was at 8, and the other one was negative because we started at a height other than 0, the ground. And so how do we find where it lands? Well, it's going to be this number right here, the opposite of what's going to be our root. It's called R, stands for root. All right, so there's a basic summary of what we looked at today. Of course, we're going to dive in deeper and take a look at each of these forms in depth later on, but that's kind of a summary of what we'll see this unit.